Now till this point what have we known? We know what is refraction and what is the cause of refraction, right? So I am making a diagram again for the refracted rays. I have a ray coming on this medium where I have a normal. It is going to bend towards the normal. This is my original path which was supposed to be followed if there is no denser medium. This light ray will what? Bend towards the normal, right? Like this. Towards the normal means in this direction. So here, what are the angles involved now? The angle at which light is incident on the surface is called angle of incidence, which is I. The angle at which light is refracted from the normal is called angle of refraction, R, right? So we have our I and R. Now go back to the what was the laws involved with the law refraction, that is laws of refraction, that sine of angle of incidence over sine of angle of refraction is called a constant, and this constant is further given a name of what? Refractive index. This is called refractive index, sine of angle of incidence to the sine of angle of refraction. So this part and this part was given by Snell. Snell's the scientist name, Snell's law. What is Snell's law? Snell's law states that sine of angle of incidence over sine of angle of refraction for a medium is called its refractive index, but this law will be explained to you in a very different way. What is this law? Refractive index is what? It is a relative quantity. See, I'll explain you what is a relative quantity. For example, there is this thing called density. What is density? Mass per unit volume. What is relative density? Relative density of, suppose, plastic would be density of plastic divided by density of water. Okay. Similarly, so relative density is a relative value where the units will cut off, will cancel out, and you will be left with a dimensionless quantity. Similarly, refractive index is a relative quantity. It is always, refractive index is always given by this. It is the refractive index of the medium over refractive index of surrounding. This is the proper definition of refractive index. Though we have few more definitions of refractive index. What else? I'm giving you another definition of refractive index. It is defined as the ratio of speed of light in air upon speed of light in that particular medium, or Vm. Okay. Refractive index is defined as what? Speed of light in air upon speed of light in that particular medium. Let me use this formula for once. For example, we know that speed of light in air is 3 into 10 raised to power 8 meter per second, right? Suppose they give us that velocity of light in glass is 2 into 10 raised to power 8. What is the refractive index of glass? What is mu g? So I will do this thing. I will apply this formula. Mu g is C upon V, which is 3 into 10 raised to power 8 over 2. This is 2. It had to be 2. 2 into 10 raised to power 8. What am I left with? 1.5. So refractive index of glass is 1.5. Now as I was telling you guys that refractive index is a relative quantity, that means this value 1.5 is basically what? It is the refractive index of glass upon the refractive index of the light or the medium where the light was traveling from. So this is refractive index of glass upon refractive index of air. So this is what the refractive index is dependent on. That is why its value is going to change if I put this glass slab in a water, just water medium. For example, swimming pool. I just drop this glass slab into swimming pool. What will happen? The light is traveling from water to this glass, right? So refractive index, the definition and the formula is going to be what? The formula is going to be refractive index of glass upon refractive index of what was surrounding? Water. And otherwise, if in case of air, it is refractive index of glass upon refractive index of air. So this upon mu A, which is refractive index of air, is basically a silent thing. You know what? In English we use the alphabet silent. There are a lot of alphabets which are silent, right? So like P is silent in many words. Similarly, mu A is hidden, and people like authors of our books are suppose us that we already know this fact. So now I have cleared you this thing, that this is the way. Now how do you use Snell's law? Snell's law, using Snell's law is very simple. So let me name this thing. This is medium 1 and medium 2. Okay. So here light is going back to medium 1 from this point. Let me draw the normals again. This is my normal, and this is my again the second refracted ray from the second interface. Okay. Now we were at this point that light is from 1 to 2, and here light is going from 2 to 1. Snell's law is very simple to know. Just remember one thing, that Snell's law said sine of angle of incidence to the sine of angle of refraction is mu of what? From the medium which is light going to the medium in which light is coming. For this interface, refractive index will be 1 mu 2, and for this interface, this is a different angle I1 and this is a different angle R1. Okay, just for example, so at here my application of Snell's law would be what? Sine I1 upon sine R1 will be equal to mu, from where to where? Light is going from 2 to 1, so this is 2 mu 1. Simple. Just write the numbers. This is the number, the source, and this is the number which is target. 2 to 1, 2 mu 1. At this interface it was 1 to 2, so 1 mu 2, and 1 mu 2 is further written as mu 2 over mu 1. This is, so this part and this part is now very easy. So this is the link which you should always write, because we are going to use this a lot of places. We will always follow this terminology. First we will write according to Snell's law, sin I upon sin I equal to, I will not use mu, I will use either 1 mu 2 or 2 mu 1. For example, in this case the light is going from air to glass, so I would be doing what? Sin I upon sin I is equal to A mu G. This is A and this is G. And after that, what I know about this thing, this will be equal to mu G over mu A. This is the simplified form of Snell's law. And second thing, the speed upon the speed in medium is another formula for refractive index of light, which can be used anywhere. So now we have two different definitions of refractive index. Number one, according to Snell's law, refractive index is what? Ratio of sine of angle of incidence to the sine of angle of refraction, but considering the nature of surfaces or nature of interface which is distributing two different mediums. Number two, the ratio of speed of light in what? Air to the speed of light in particular medium.